Hi, Wellman. This is JiayaoHuang, also go by Olivia. I am from Physics 100 class. Here is my measuring reaction time presentation. First, how to make my reaction strip include the material and the equations used. The material I used are paper, pencil, and ruler. The first step, I make the length of paper strip around 0.3 meters. Then I used the ruler and spaced the stick by every 5 millimeters. The formula I use is H equal to 1 over 2 times G times T squared. From this formula, I can get another equation. T equal to square root of 2 times H divided by G. The unions of this formula, time is second, height is meter, gravity is 10 meter per second per second. The equations I used it in the Excels. As I showed in last slide, reaction times is equal to square root of 2 times distance and divided by G. Here is the example. If a person catch the street point at 0.015 meters, the distance will be 0.015 meters. Then we plug 0.015 meters into the formula. We can get this. The person reaction times is equal to square root of 2 times 0.015 meters and divided by 10 meter per second per second. So the result is 0.05477 meter per second. As we know the distance, we can get the reaction time. Here is the chart I made it by Excel. Distance for length versus reaction time equal distance increments. As we can see, longer for distance means slower reaction. Shorter for distance means faster reaction. Here is my data of the reaction for each female subject, with and without the extraneous stimulus. The average without the extraneous stimulus is 0.143. It is faster than the average with extraneous stimulus, which is 0.172. The male subject data, the average with an extraneous stimulus is also slower than without an extraneous stimulus. To compare the difference for each subject and average reaction time with and without the extraneous stimulus, it is obvious that the extraneous stimulus can affect the reaction time. In most times, the reaction time will be slower with extraneous stimulus. In your opinion, did the extraneous stimulus you use affect subject reaction times? In my opinion, the extraneous stimulus I used affect subject reaction time. With the extraneous stimulus, the subject cannot concentrate on catching the strip, so their reaction time will be slower. Otherwise, without the extraneous stimulus, the subject can catch the strip faster because they can pay full attention on it. Can you come to a conclusion about reaction times of males versus females when there are extraneous stimulus or minimal extraneous stimulus? According to my data about the reaction time of males versus females, where there are with or without extraneous stimulus, the females are always faster than the males. However, this cannot be a conclusion because the conditions of experiment was limited. Do your results have any bearing on the effect of talking on a cell phone while driving? Discussed. When a person is talking on the cell phone while driving the car, the action talking on the cell phone is an extraneous stimulus, so the driver cannot pay full attention on driving. The driver's reaction time is declined. As the result, the driver's reaction time is slower when there is an accident. Imagine that you were measuring the reaction time of someone with an extremely slow reaction time, greater than 2 seconds. Would the current car shock be suitable? Why or why not? According to the formula, distance is equal to 1 over 2 times 10 meters per second and times 2 seconds squared. It is equal to 20 meters. However, the length of my strip is only 0.28 meters. Thus, the current car shock wouldn't be suitable. How might you measure this person's reaction times accurately? Using a special timer that has a start button and end button in each side. As I click the start button, the person has to press the stop button as soon as possible. Imagine that you were measuring the reaction time of someone with an extremely fast reaction time, less than 0.1 seconds. Would the current car shock be suitable? Why or why not? According to the formula, distance is equal to 1 over 2 times 10 meters per second times 0.1 second squared. It is equal to 0.05 meters. The length of my strip is 0.28 meters. It is quite enough for 0.05 meters. Also, the strip was spaced by every 0.005 meters. Thus, the current car shock would be suitable. How might you measure this person's reaction time accurately? I will make a new strip with much short intervals. For example, spacing the stick by every 1 millimeter. The shorter intervals in the stick, the reaction time will be more accurate.